Yeah, that's about right. I'd say we're anywhere in the 20-inch range, but yeah, that's definitely on the high side.
Do you think we'll see, a 50 or a 60-inch wheel if things keep getting bigger and bigger, or are we now facing a new design challenge at that threshold to say, okay, well, we can't go any wider, we can't go any taller, or what comes next if we have to get more and more?
Right. Yeah, my wheels were already spinning as we were talking through that, and that is interesting.
All
I don't.
puns intended with the
Yeah, yeah.
wheel.
My fan wheels were spinning. Yeah. Yep. Um, yeah, that's an interesting question because I can imagine a few solutions that might look different than what you have.
I could see us getting to a point where the stresses or the speeds get so high that you're now into either different rotor design or different, I don't know, materials even. I don't know what the Inco material stress limit is, but I would imagine we're going to reach another uh, design evolution as the turbines get bigger and the ammonia demand gets larger and the corresponding skids get larger. What does that look like from a fan sizing? We're going
Oh
to
boy.
reach another limitation, I would think.
Yeah. So the fan design that we typically use, it has some inherent design characteristics that actually it is low stress, and as we start to get into bigger or higher flows, essentially the fan wheel has to get wider, or
Okay.
the fan rotor, or whatever you want to call it. It has to get wider, and when you start to do that, then the stresses they change, right? So actually, if you get up into the 20 or 40,000 ACFM, I don't know where we're going to end up. It might mean two fans in parallel,
Now we're
right?
talking.
So if you need 20,000 ACFM, and we're getting out of a design range at 3,600 RPM, it very well could look like two 10,000 ACFM fans or two 15,000 just to meet that flow. And when I
Okay.
say in parallel,
No, I'm with you.
basically you have piping that splits, goes through two operating fans, and they each offer that amount of flow, if that makes sense.
It does. In fact, to your point, I think we get to a certain size where we need a skid on each side of the unit, where one skid with two big hot gas fans on it is only feeding half of the
Oh yeah.
exhaust system. We've already seen some of these advanced simple cycle designs. The width gets to a point where you can't do that with a span of AIG lances without them sagging, right, because of the distance
Oh
of
right.
the
Yeah.
piping. So now you're into several supported zones of adjustment to put the ammonia where the NOx is in the exhaust duct. But to your point, we may need to feed on either side of that unit a dedicated skid with two fans that are only running at 50% of the total flow, because now we're into such big ducts and we have to distribute all this gas and everything else. It's a design challenge, and more of these